Next question is 9th question A part with need diagram explain the construction of N channel JFET. Okay, it is asked for 10 marks from January February 2021 question. So N channel JFET. So need diagram explain the construction. So before the construction, let me give what is your symbol of your N channel JFET. So this will be your symbol of your N channel JFET where the three terminals is going to be your gate, source and drain. Okay. So construction of JFET. So moving on to the construction. So the diagram will be given by, you will have N channel means you have an N type semiconductor which forms a channel to which two heavily doped P type semiconductor will be embedded, right? So two P type semiconductor will be joined together and this will give you the terminal called as gate. Okay, gate, and two N type will be connected, will be taken the terminals as drain and the lower one will be your source. Okay, it's a resistive element. Okay, so these are the three terminals which are taking. So since there are N and P, you will be having a small depletion layer. Okay, two N and P type of semiconductor. So this is going to be your depletion layer. So this will be your N channel. So this is your basic diagram of your construction details of your N channel JFET. JFET stands for junction field effect transistor. Okay, so you have two PN junction formed. So when we go on to your working principle of your N channel JFET, it works in two cases. Okay, so case 1, what is the first case? When VGS is equal to 0. So your current flow is controlled by your gate to source voltage. Now we are taking a common source configuration where your source will be grounded and your input voltage is going to be your gate to source and the output voltage is going to be your drain to source. Okay, so for the first condition, when VGS is equal to 0 and you are going to give VDS, okay, and positive VDS, little bit positive you are going. So how will be your circuit now for your case 1? So let me take this as your case 1. So how will be your circuit be configured? So this will be your P, right? And you will have the connection which is going to your gate. This will be your metal contact. So I am going to give only the important points, okay? Drain and source. Now source will be grounded. So now VGS is equal to 0. So you are not going to, or you are going to short VGS. So you are not going to give any potential across VGS and you are going to apply a little bit voltage, that is VDS. So what will be the condition now? The electron starts flowing from source to drain. Okay, so the electron starts flowing from source to drain. This will be the direction of your electrons. And what will happen? Equal and opposite charge carrier. So ID, the current flows when electron starts moving from source to drain, the current starts moving in the opposite direction, right? So the current starts moving from drain to source. So your depletion layer, now it is, you will be having the depletion layer width to be increased. Okay, so this will be the depletion layer width increases. This is the normal working principle, right? So what will happen now? So here it is N and P, so it will be the depletion layer width starts to increase. So as the VDS increases, the depletion layer width increases and it touches each other at some instant of time. So what will happen? Now the current will be saturated. So is it looking like a river, right? It's looking like a big river. Circuit will just look like a river or a water tank where you have the water flowing, okay, with a high speed, but as there is a pathway which is getting narrower and narrower, right? So you have only a very small narrow path for your water to flow, but at that instant of time from the source, if you have heavy water flowing also, you feel like the water is getting saturated because it doesn't have space to for the water to flow on. Okay, just like that, an example, after when your depletion layer width gets narrower and narrower at a particular instant of time, you will get the current to be saturated even though the value of VDS goes on increasing. So that I will be explaining it by your characteristics. Now you have the second case, that is your case 2, when VGS, now I am applying VGS is equal to negative. So it works in two conditions, okay, when VGS is equal to 0 and when VGS is equal to negative. Now when VGS is equal to negative, what will happen to your circuit now? So you will be having two P type and this is going to be your N type. Now already you are giving a drain, so this will be your connection of your gate, right? So gate. Now this was your previous condition when you have applied VDS, right? And this is going to be your source. Source will be grounded. So this is your VDS. Now what will happen if when you apply VDS, already your depletion layer width is increased. Now what will happen when you apply VGS, negative, positive? When you apply negative, positive, here it is negative, here it is positive. Again there is reverse bias, right? So the speed of the depletion layer width increasing will be very, very faster. So the current will get saturated in a very faster amount of time, okay? So it will during this condition, what will happen? Along with your VDS, when I apply VGS, the reverse bias across your VGS further increases your depletion layer width at a very faster rate and the current reaches your saturation very fastly, okay? So that is the two conditions of when VGS is negative and when VDS is equal to positive, okay? So these are the two conditions. Based on these conditions, so this is your construction principle. Now based on these two conditions, you are going to draw the two characteristics. So what are the two characteristics you have? The two characteristics, one is called as your drain characteristics. Drain characteristics is also called as output characteristics and other one is called as your transfer characteristics, okay? Transfer characteristics or your input characteristics. So what is your output characteristics? The graph which is drawn between your output parameters. Here the output current is equal to your current drain current ID and output voltage is equal to VDS, which is equal to volt, okay? Now what will be your value you are getting? In this case, what will be done? As you increase VDS, the current start increasing. After some point, the depletion layer width increases such that it touches each other and your current reaches the saturation maximum. So this current is called as IDSS or your maximum drain current when VGS is equal to 0. Now I am going to apply when VGS is equal to negative, right? Now the current reaches saturation within small amount of time. 2 volt, VGS is equal to minus 3 volt, VGS is equal to minus 4 volt, etc. So what will happen? The current starts saturating in a very small amount of time. So once it reaches the pinch of voltage, so when VGS is equal to minus, for example, if I take this as minus 4 volt and minus 5 volt, your drain current is going to be 0 below this value. So this is called as pinch of voltage in which your drain current becomes 0. So you have different regions. So this region is called as your ohmic region, resistive region, and this is your saturation region, okay? After this point you will be having a breakdown region whereas your current keeps on increasing. So this is called as your breakdown region, and where you don't have your current, that is ID is equal to 0, which is called as cutoff region. So it can also act as a switch like saturation and cutoff region. So this will be your drain characteristic. So you know that the current equation is given by Shockley's equation. ID is equal to IDSS into 1 minus VGS divided by VP the whole square, okay? So now it works in two conditions, VGS is equal to 0 and when VGS is equal to negative. Now what is the transfer characteristics of this? A graph which is plotted between your current and your input voltage. Input voltage in this case is equal to VGS. Here it is negative, right? So it is minus 1 volt, minus 2 volt, minus 3 volt, minus 4 volt, minus 5 volt, etc. So the current will be maximum when VGS is equal to 0 and it starts decreasing when it reaches pinch of voltage. The current becomes 0, keeping what as constant? VDS, output voltage, as constant. So if I take this as 10 volt or 5 volt, keeping this as constant, your graph which is plotted between your drain current and your VGS is called as your transfer characteristics. So you have these two characteristics for 10 marks. So you can explain the two conditions, working principle of the two conditions when VGS is equal to 0 and when VGS is equal to negative. Give the two construction and along with that of your characteristic curves. These are the important points for your construction of your N channel JFET.